Welcome to the last lesson of Chapter 6, and today we will be learning about selection of statistical charts. Learning goals. Understand the characteristics of different statistical graphs and being able to choose the appropriate statistical graph according to the real-life problems. Being able to obtain effective information from the statistical chart and make correct decisions. Introduction. As shown in the graph, it reflects the population situation published by the newspaper in a certain year. Take a look at what information this newspaper provides us. So as you can see over here, this is a bar chart from the publishing of a newspaper from each certain year right here. Now I want you to think about what type of information we can get from this. What type of data does this represent? Well, for me, I definitely see a growth of population starting from the year 1957 all the way to the future 2050. And this bar graph right here, since it has many different bars, it is very easy to compare the different quantities of data this is showing. Choosing appropriate graph to express data. So right here is a world population graph. And this is showing the exact same data as the last one on the last slide, except in a line chart. This is a pie chart and another bar chart. And this time, as you can see, it is the world population distribution, which is, Europe, Africa, North America, the Latin America, and the Caribbean, and Asia. These are all pie charts in the world population graph, the world, not just one particular country. According to the picture above, answer the following questions. What does the three statistical graphs mean? So, what type of data do we get from the charts? Here we see the 2050 world population distribution, and this is population from the billions. And there's Europe, Africa, North America, Latin America, and the Caribbean, and Asia. And then we can actually really well compare the amounts of population on all the continents. This is another pie chart. Remember, the pie chart is known for representing percentages of the whole. And this dark blue navy area here is North America. The aqua colored is Europe. Pale green is Africa. Dark green is Asia. In Latin America and the Caribbean is lavender. Over here, we see the growth of the world population as a whole. And this is, again, population of the billions. And this is the year. So we see it growing. Then there's a very rapid growth from 1999 to 2025. In the future, we believe that it will come to about 90 billion in the population at 2050. 2. Can you see how the world's population is changing from the statistical charts? And what we just covered was that we saw the line chart, and it was showing how rapid the growth was growing. And the pie chart and the bar chart shows more of more comparison between different parts of that data, and the line chart kind of shows the changes of that data, how it changes. 3. How many billion will the population of Africa reach in 2050? Which graph did you get this data from? Well, now let's try to search this data. So in Africa right here, it shows from the billions, it's almost reaching 20 billion. About 20 billion. And we got this information from the bar chart, the last one. So that's the answer to problem 3. Problem 4 asks, in 2050, the population of Asia would be more than the total population of the other continents. From which graph can you clearly get this conclusion? So you could kind of stack these up I guess, and be kind of looking at how Asia is going to be taller than the other continents. But what I clearly get this from is actually from the pie chart, because you can view this whole thing as one area, and of course Asia is this dark green area over here. So it is very, very easy to see that relationship, how the population of Asia is greater than the other continents combined. 5. Compare the characteristics of the 3 statistical charts. So what type of data can you get from it? This compares each of the continents, it just compares each of the continents' population, but that's just about it. You can't really compare it in any other way unless you want to rewrite these values over here. But the pie chart, it's basically the bar chart. There's lots of comparison in here, but you can compare with anything. You can compare the sum of, say, Asia and Europe. You can compare the Americas against the rest of the world. You can compare one continent against the other continents. So this pie chart, putting them all next to each other, you can see how much one piece of data takes up in the whole world population. And in this line chart, I see the changes of the world population from how it was only around 30 billion in 1957, and now, not now, right now it's just 2021, but in the future, in 2050, it will reach 90 billion. And as you can see, this is the whole population's graph, not comparing. So there is no need to break it up into all of the continents. So here's a conclusion. The bar chart can clearly show the specific number of each item and the size relationship between them. And as you can see, this is actually the size relationship between each item. The graph can clearly reflect the changes of the same thing in different periods. And if you graph multiple lines on here, you can also sometimes compare them. So see these points, they fall on the same y-axis. These fall on the same y-axis. This point right here, this point, you can compare those heights. Then for the pie chart can clearly indicate the percentage of each part in the total and the size relationship between them. And now, the size relationship isn't just the size relationship of each item. You can, say, add the white parts together, add this aqua part and this white part. You can do more complex relationship comparisons in between them when you have a pie chart. Activity 1. Make an appropriate statistical graph to represent the following data. And so right here we have a table of the following data about the incubation periods of different types of birds. Then what we want to do is create an appropriate statistical graph to represent the data. So first, I want you to go ahead and use the steps of creating a statistical graph from last time. And I want you to first whip out your notepad and do it on there for now. Okay, are you done? Now let's look at what my table looks like and compare it with yours. Answer. The data is a specific quantity, and each part is independent of each other. So we can use a bar chart as shown in the figure below. So can you use a pie chart? Sure. But you can't really use a line graph, because a line graph, you're not trying to show any changes in here. It's not all about one item and its changes. It's about different types of items. You want to compare those. So it's either pie graph or bar graph. But in this case, we were making a bar graph because that was easier. Or we thought that was more, that fitted better into the situation. So let me show you how I did this. First, I found the highest number of days. Here is 30 days. So high, low, lowest value. And then we have the range. Remember, the range is the difference between the highest value and the lowest. Then we would find the highest value. Here is 30 days. The lowest value, that is 16 days. And then the range, 30 minus 60, 30. Well, this, we don't have to find the range right now because it's not a frequency table. Then we find the range, and then over here, we see how this isn't just going by, it's not going by ones or 0.5 because that is not a appropriate decision to make these tick marks. So we chose from it to be from 0 to 40 counting by tens because we thought that was more appropriate. But I mean, by fives it would also work actually. Then we decided the height would be 40. Remember, the height can be the large tick mark can be a little bit larger than the highest value. Then we would graph them. So on the bottom we wrote chicken, duck, goose, pigeon, and turkey. And then we are going to then create the bars on top of these names to show that this one is chickens, this one is ducks, and so on. So then we graph. The chicken is 21 days, and over here the closest to it is 20 days. So that would be like, this is 25. Actually, so this is 24. It looks more like 24. So it would be more about 21 right here. So that's the height of the chicken. Ducks and gooses are exactly 30, so we could just mark them to 30 right here and then hit it in. And then we have the pigeon. The pigeon is close to around half way between 10 and 20, so that's where we put it. And the turkey is 26 days, so also around right halfway between 20 and 30. But remember, this is 26 and this is actually 16. And then we still have to remember to add in the chart title. Remember, this is very important. And then the key, because, we don't know. Remember, this key can also come right here. So we can write days over here. And this key, if we didn't have this key, we will be like, well, what's the bar even part of? I mean, we know this is a incubation period bar graph, but we don't know what this green thing stands for. Is it, seconds, years, months, or days? So now if we added that key, we would know it would be days. Activity 3. In order to improve the long-distance running performance, your coach insists on exercising and records a score of 1,500 meters every Sunday. If you want to clearly see the changes in the coach's performance, what statistical chart would you choose? And this is the statistics of the coach's 1,500 meter performance change. So let me quickly explain what this whole thing means. So you have a running coach, and he is insisting himself to exercise and records the score of 1,500 meters every Sunday. So if you want to clearly check him, making sure like, hey coach, are you actually promising on your promise? You want to look at his data, and then I want to ask you, which statistical chart would you make? So, and this is the data. Week number, which is 1, 2, 3, 4, 5, 6, 7, and this is the points. So, it seems like there's a rubric, and you have to find how much points he earned. So, statistics of the coach's 1,500 meter performance change. So, this is the statistics. And, as you can see here, since this time it's more about in the 0.5s, the distance from each tick mark here is 0.5 because that was more of a reasonable tick mark range to make. And then, so this is the statistics. Compare features of tables and graphs. Which, if you were gonna clearly see the changes in the coach's performance, which chart would you choose? Well, remember, the line graph right here is very known for clearly seeing the changes in of something. Seeing the changes. So I would pick the line chart because I can see how at first he was having this nice, routine of 7.5, but suddenly it dropped down to just 7, and then ever since that it's been going down and down. It seems like, as a conclusion, that he's been losing that habit of always on that around 7.5. Activity 4. In order to understand how readers like the 4 columns of the newspaper, the Massachusetts Morning Post conducted a questionnaire survey on readers, asking readers to select one of their favorite columns. To know exactly how many people like each column, a blank chart could be drawn. To know the percentage of the number of people who like each page to the total number, a blank chart could be drawn. So the answer is to know exactly how much people like each page, a bar chart can be drawn because we know that a bar chart is known for knowing exactly how many people like each page. And a pie chart could be drawn for comparing the percentages and the relationships between each piece of data. Activity 5. The students of a meteorology team recorded their monthly precipitation after beginning of school, and the data obtained is shown in the following table. Please choose an appropriate statistical graph to represent these data. The drawing of the statistical graphs does not need to be unique. For this problem, both line plots and bar graphs can be used. We should learn to analyze data from multiple angles. So, saying right now I'm giving you a task, and from this table you have to choose an appropriate statistical graph to represent the data. And it's fine if you come up with multiple that might work for here, because it's good to analyze data from different angles. Okay, so now I'm going to go over the nice choices we could do for this data. So here is the September, October, November, and December. And one way we can do this is find the exact number of participation, the exact number for each month. And finding the exactly how many exact value for each, we know that there can be a bar chart. Then we can find the relationships between how many how the percentage between the participation from these the precipitation from all of these months, and then put them together to find the relationship between their percentages. So we could get a pie chart for that. Then we can use a line chart. A line chart we can see over the course of September to December in this year. Over the course of September to December in this year, how has the amount of precipitation changed starting from the beginning of the school to now? So we could also use a line graph. So as you can see, we can use all 3 of the types of charts and graphs we learned in this chapter to clearly analyze this data. And using all different of these, we can conclude different conclusions from here. So from the bar chart, we can see the exact amount of precipitation from each month. From the pie chart, we can clearly compare them to each other on percentage. And for the line graph, we can see how they changed, all connected together. So discussions. Can you talk about how to choose these three statistical graphs reasonably? Well, when choosing a statistical chart, we should choose an appropriate statistical chart based on the characteristics of the three statistical charts, the characteristics of the data itself, and the needs of the research problem. So we know that the bar chart, the line chart, and the pie chart all have different characteristics in them, depending on what kind of information we want to obtain. Say we want to see the percentage comparisons of the data. We can use a pie chart for that because we know that the pie chart, it is very easy to get that kind of information from the pie chart. If we want to see a change of a event or something, or say an experiment over different times on different times and dates, we can see the change easily by graphing a line chart. We can also find the exact amount of data and compare those with a bar chart. Using a statistical graph to represent unique features of data. The sales volume and prices of two wines A and B in the recent years are as follows. And here we see a table about the data gained by production of price of brand A wine. So this is the year, let me write that, year 2002, 2006, 2010. Then there's the annual sales volume per 10,000 bottles. So if it says 10,000 bottles, this means that this 150 here really is 150 10,000. And so in 2002, the annual sales volume per 10,000 bottles was 150, 2006, 180, 2010, 210. Unit price of the year per dollar. So there's $40, $50, $60. Production and price of brand B wine. So here we see the same graph, but except this is brand B. So this is also the year up here, 2002, 2006, 2010, and it says volume per 10,000 bottles is 160, 180, 200. And we have the unit price of the year, 40, 50, and 60. So, according to the above statistical table, some people have produced a broken line plot of the price changes of A and B wines. And here we see two line plots. This one is the prices of wine A. This is the year, and this is the unit price per bottle. This is price of wine B, same thing. So let me ask you a question. Which kind of wine do you think the price has increased faster? Why? Is this consistent with the feeling of the line chart drawn above? Why does the image give people such a feeling? So, what do you think? Which kind of wine do you think the price has increased faster? Well, I personally think that the wine A brand was increasing faster because in here the slope is more tilted than this slope. This slope here is kind of going this way. This slope here is going this way. So it's obvious that this slope right here is steeper. But is this really the case? Is it consistent? Why does the images give people such a feeling? So now I want you to pause a moment and ask why. Why does this give people such a feeling? Okay, now I want you to look at something. Over here, it's 30, 40, 50, 60, 70. Over here, it starts with 30. They both start with 30. But it's just that this one jumps 10 each time as a tick mark, as this one jumps 20 each time. So it would actually make sense. It would make sense for this to look flatter because the same so-called side slope is graphed on a larger graph. Say a larger graph chart. So this would look smaller because this about is halfway between 30 and 50. So this would actually be 40. In this case, I'm actually talking about the y, so this way is up, not this way. And this over here is 40 as well. Then we move here. These are both 50. This is also 50. And here, this is 60. 60 is halfway in between 50 and 70. So this would make sense for this to be 60. So really, the values are the same. The slopes are the same. It's just that when you look at it, because the tick marks here have a wider range, it would look like that this grows slower than this, the price of wine A, but really it grows the same. So 2. The sales staff of Type A wine made the sales information of Type A wine into the following bar charts. Please also make a bar chart of the annual sales volume of Type B wine and the figure on the right. Now, alright, you come back. Did you graph the bar chart? So all you had to do in here was remember the tick marks from these are different. Tick marks. This one is 250. This one is 220. And even here, this starts at 120 while this starts at 0. So now we're to create this bar graph. We're going to go over and we're going to see the data from here. And according to that data, we would graph here. So for the one that's 2002, we would see that just a little around above 150. For 2006, it's a little bit above halfway between 150 to 200, maybe say 180. And in 2010, it's exactly 200, so that's good. 3. Does a true bar graph feel the same to you? In a bar chart drawn by the sales staff of Type A wine, how many times does the annual sale of Type A wine in 2010 look like in 2002? Discussions. In order to compare the change of speed of certain two statistics more intuitively, what should be paid attention to when drawing a broken line statistical graph? 2. In order to more intuitively reflect the proportional relationship between several statistics, what should be paid attention to when drawing bar statistics? So I want you to answer these two questions on your notepad and just really deeply think about these two questions. Why would you need to ask them? Are these worth asking? Well, what should be paid attention to when drawing broken line statistical graphs is that you have to look at the check marks. Check marks. Because if the check marks are different, the whole thing is based on the check marks in a bar chart and a statistical graph, so in a line statistical graph, so that's important to take. Part 2 and 2. In order to more intuitively reflect the proportional relationship between several statistics, what should be paid attention to when drawing bar statistics? Same thing, check marks. So here's a conclusion. Draw two line plots. When comparing the changing trends of the two statistics, attention should be paid to the consistency of the horizontal, vertical coordinates. When drawing a bar chart, the starting value on the coordinate on the coordinate should start from 0 to avoid misleading and illusion. Class summary. In this lesson, we learned about the selection of statistical graphs, and that was broken up into two sections: selection of statistical graphs and illusions caused by statistical graphs. In selection of statistical graphs, the two main points we worked on was the characteristics of the three statistical graphs and reasonable choices of statistical graphs to represent data. In illusions caused by statistical graphs, the three main focuses was notes on bar graphs, notes on line plots, and illusions caused by pie charts. The two skills we learned today was understand the characteristics of different statistical graphs and being able to choose the appropriate statistical graph according to real-life problems. And 2, being able to obtain effective information from statistical graphs and make correct decisions. So I hope you like watching the videos of Chapter 6. And here we learned all about different types of ways to analyze and express data. We talked about different serving methods, and now we're talking about the characteristics of these different statistical graphs, and when solving problems, which ones can solve which type of research requirements. So I'll meet you probably in chapter 8 or something, and see you next time, and have fun with chapter